Hello and welcome to another episode of Scala Space podcast. I'm Łukasz Biały, Scala developer advocate at VirtusLab, and today my guests are staff engineers at fintech companies, Voytek Pituła from SwissBorg and
Hello.
Raphaël Lemaitre from Ledger.
Hey.
We will talk today about something that is, I believe, very familiar and very nice for Scala developers, which is domain modeling. This thing is something that is very popular and very easy in Scala. Today we are trying to discuss how it works, what is the best that we can do in Scala in domain modeling, and why Scala exceeds all expectations in this scope. So I would like to start with a question about the domain in which both of you work. Scala is very popular in fintech. It's one of the largest domains where Scala is professionally used. I would like to ask you if you could tell us why your companies are using Scala. Why is it a good fit and why that choice was made? Voytek?
That's a good question. I actually wrote an article some time ago, so whoever is interested probably can take a look. But the bottom line is that our CTO had experience with both Python and Scala, and he also knew the cost of bugs in financial environment. So he decided that Scala is a much better choice when a single mistake can cost you the whole company.
Okay, Raphaël?
Yeah, that's kind of same for us because Scala expressiveness and type safety and so on, it brings it's easier, faster to write some with some code with less bugs, or at least less bugs detected in production.
Okay, so in both those cases, the biggest sell point I would say is type safety, basically.
Yeah, type safety and developer productivity also.
Yeah, immutability, but yeah. I think that because the argument I often hear is that there is very little data, if that's actually true. And the thing that I like to say is that even if it's just a statistical or like hypothesis, that there is a chance you might have less bugs in strongly typed functional programming, that's already good enough for the fintech. We take all we can to save ourselves from trouble.
Sure.
Indeed.
Okay, I guess we should just start with defining what do we mean when we talk about modeling the domain. So, could you tell us more about what do you think domain modeling is, and how does it actually look like in your working experience? Raphaël?
Yeah, I think we have to there's two things in domain modeling. There's the data modeling, which is basically what everyone knows about the domain modeling. So how to translate the business terms in code and in Scala, and the behavior modeling. What are the interactions between our code or different systems and so on. So yeah, that's the two big things, and having a good one and a shared model, not just between devs but in the whole organization. It brings quality, it brings it is communication and so on. And
Okay. Voytek, is there anything that you would like to add to the definition itself?
Not really. I was thinking on that question before the podcast, and what I was able to figure out is that the domain modeling is really to bring the code as close as possible to the business domain, to the language and to the problems that you're solving. So whatever helps in that is domain modeling, in my view.
Yeah.
Okay. So going forward with this, what do you think is the impact of the whole movement? Because it was a movement and it was very popular a few years back with domain-driven design. What would you say is the impact of this movement on the industry, especially on fintech industry?
I think one of the biggest impact is the spotlight it has put on naming and ubiquitous language, for example. Because I remember when I started to work 25 years ago, devs and business people didn't speak at all the same language. And now, at least with some work from both sides, and the use of this ubiquitous language, it's easier to work. We don't lose time. Let's say when an issue arises, and so on. So yeah, but it's not so easy because naming is hard. And it was Camus that said poorly naming things bring adds misery to the world. So it's totally true in dev.
Yeah, I agree with that. I have the very similar feeling. But I think some people might don't know exactly what we're talking about when we say ubiquitous language or this kind of problems. So maybe to make it a little bit more tangible, like for example, if you see something called transaction in your system, it can have very different meanings, and then you end up on a call with the stakeholders, like the business people, and you say transaction, and the goal is that you mean the same thing, right? And that gets tricky really fast because in scope of the same company, the same system, the same word can have multiple different meanings. Then you need to translate between those meanings between different departments and different domains. But that's the goal. Like you have to speak the same language with the people you talk to.
Yeah, I guess it's also easy in particular context of this transaction word. It's also easy to mix up technical domain with the business domain.
Yeah. In this case especially.
Yeah. Okay, so I think we know what we have in mind when we talk about domain modeling. Let's talk about how Scala enables this. What can we do in Scala that improves this? So Scala is a weird child in the class, I would say. It's a mix of object-oriented language with a functional language, and it's kind of unique in this regard. I know that all of the older object-oriented languages are slowly evolving in the same direction, but Scala was always the more functional. So we have had features that purely functional languages like Haskell had years ago. I think that this would also mean that our idiomatic design in Scala would differ from a design that would be given as examples in all the books about DDD, which mostly use object-oriented languages. So, the first thing that comes to mind is that which is really different from, let's say, Java, is that Scala developers tend to make things immutable by default. So mutability is the exception. I would like to ask you how immutability by default impacts the models that you create. Are there any benefits of this practice, or does it make things harder?
Yeah, I can probably comment a bit on that. So for me, it's equally correct to model the domain in mutable and immutable way. It's just more convenient in immutable, but then I sometimes hear that, okay, the word is not immutable, right? It mutates all the time. And my answer to that is that that's just a matter of perspective. Like, if you look at the world at any particular point of time, it's immutable. And only when you make a transition to the next point of time, it mutates to a new state. And that's exactly how we model things in functional world. But this brings us a little bit to the object-oriented versus functional, because in classical object-oriented, you had methods attached to object and you mutated those objects through those methods, right? If you no longer mutate, why do you tangle behaviors with data? And for me, at least, the answer is because of human psychology and nature. It's like just to group things together that work together, belong together. So often, like, if you think about a function with two arguments, how do you choose which object that method belongs to? Should it be on the first or the second argument? But often than not, there is a domain connections that is stronger with one of those, and then you group those behaviors around those objects.
Cat eats food situation, like.
Yeah.
Yeah, I think it makes sense. So you keep this practice. So it's not free from functions floating in separation. No, it's still data and behavior.
No, I personally wouldn't be able to navigate in the world full of free floating functions. That's actually I was not very enthusiastic about top level definitions in Scala 3, but I think they might have their uses.
It really needs some discipline to do this well and to navigate easily in free floating functions. I'm also group data and behavior together because that's a natural thing to do.
Okay, I'm happy to hear that this part of object-oriented design is still present. We didn't ditch that. We do have some things that are quite unique to functional languages, like algebraic data types. So basically things that are sealed interfaces that have members that can be enumerated and they're non-statically. That's something that also is being incorporated into Java as we speak. I'm following the development of those features in Java, and they're slowly moving towards something that we have known for over a decade here, or even 2 decades. I'm not sure about how early they appeared in the Scala compiler, but I think they were there. It's possible that they were there from the beginning. So ADTs, so algebraic data types, are very famous in Scala ecosystem. I would like to ask you how they impact domain modeling.
I actually extracted a little bit of a example from our code base, so I can maybe show it. So we have something tangible. Yeah. So from the beginning of this year, I work on more on the accounting domain, and in the accounting domain there is a field called the accounting equation, the fundamental equation. It's just how you express things in a double entry bookkeeping. I'm not going into explaining that because that would take a lot of time, but it's like a very core principle of accounting. It has nothing to do with software development, right? So that's like as much of a business domain as it can be. And I just extracted how we can model that. So we have an account, which is just a label for funds. And then those accounts have types, like you have assets, liabilities, equity, income, and expense, and they all have to sum up together to zero in that system. So, for example, you have a current balance, the money you can use, that's assets. You have deposits and withdrawals that are equity. I'm not going to go into why equity exactly, but you can imagine that when you the core idea of the double entry bookkeeping is that if you add to one place, you have to subtract from another place or add based on those signs. So that's why we model it like that. And that's actually an IDT. We model it like that. We can then ensure certain invariance to that. Now IntelliJ is playing tricks with me. I cannot scroll, but you can still see some example. So if we have an operation, we can ensure that the right type of account is used.
Yeah.
Right. And we can also introduce the connection between the accounts, right? So we have some managed product, whatever that is, in that it connects to 4 different accounts, and we specify all of them with very precise types. So that's something that, yeah, I just simplified a little bit, but it's something that we have in the code base.
Okay. Can you move the cursor, or is it completely hanging?
It was hanging only when I was presenting the
Screen.
The window. If I present the entire screen, I can show the whole thing. I think it won't lag.
Let's try.
Yeah, but there is not much more. Like you missed just missing implementation. So.
Oh, okay.
Yeah. So I went for a very simple example. The point here is that we express something that has zero connection to software development with the types and ADT in that case.
Okay. What would you say the benefits are if you model things in this way? I guess we could just, what happened if we had a Java interface account and it would be open interface? So what would be the difference in implementation and safety of the implementation?
Yeah, so you could define any kind of new type, right? Like new type of account, and then your model diverges from the business domain, because in business domain there are exactly 5 types and nothing more. Like that's coming from the business, and you don't have a say here. Like the developer should not be able to open that hierarchy.
Okay.
Yeah, it brings immutability to the definition because the set of possible instances is finite. Yeah, that's a big.
I guess it's worth to add that compiler will then also check that if you ever need to match on any account, you can always expect the compiler to tell you, okay, you missed one, you missed 2. So that's also a safety approach.
And also it allows do pattern matching on your domain. So it's really the code is way better, I think, with pattern matching. It's clearer than a big. I remember in Java a big if else if with instance of or visitor patterns. That's
definitely more readable.
Yeah, and safe.
Okay, so Raphaël, would you say that Are there any issues that you know of or have encountered with ADTs in your career as a Scala developer? Are there any problems that are worth mentioning?
Some we're using now exclusively Scala 3 in Ledger since 2022, I think. So for ADTs, we are using principally enums, which is great, but there's just one point that when we are using some instance derivation, it doesn't work. So we have to manually derive things, let's say for JSON encoding or something like this. I hope it'll be fixed soon, because it's I really love enums, and I'm using it as soon as I can. So I really hope it will be fixed in the next versions.
Yeah, hopefully. I know what you mean. So the problem is that if you do derives clause on the enum itself, you have to make it automatic for the member types of the enum, right?
Yeah.
Yeah. Okay.
I think there is one more issue with ADTs, and that's the name. I think the name can be quite intimidating for people from non-functional backgrounds. Like if you hear algebraic data types, it might automatically instill fear in you. So that's one small issue, and I think it only will get better because all other mainstream languages are trying to get there.
But yeah, I agree. But it's also the case for a lot of language we are using in FP. So
yeah, that is a bit of a problem, right? So we have algebraic data types, but if you name them products and coproducts, it doesn't make the situation any better, right?
No. Maybe closed hierarchies is slightly better, but still quite enigmatic. So I think it's just the thing you have to learn. And to be honest, the object-oriented world is not any better. Like you have the design patterns that, they use real-world names, but still don't carry any meaning if you don't know them up front. So it's just names you have to learn.
That's true. I actually, thinking about it right now. So I think just enums and case classes or records, I think that is kind of brief enough and carries the meaning that we would like. I guess enums are universally a closed set everywhere where they are implemented. Are you familiar with any language where they aren't?
But I think they're less closed in Scala, right? Because in traditional meaning of an enum world, you close also the instances. Like you have a finite set of instances with the Scala enums and case classes. Like the record can be part of an enum hierarchy, and it can have infinite number of instances.
No, true.
So that might be better because you use the name that is already known, but slightly worse because you give it a slightly new meaning.
Yeah, override. Yeah. Okay. Having talked about that, let's go into how we can leverage the powerful type system that Scala has to improve the modeling. So we already went through creation of records, so case classes. We can create a class that has a set of fields and it has its own identity based on the members. We have enums and sealed traits, which give us the exhaustivity, so closed sets. What about precision of modeling? So in DDD, there's the concept of value objects, which are used to make some concepts very easy to discern from other concepts and to prevent errors between categories of stuff. So if you have two things that are strings, there has to be something to make them discernible, so that we can make them distinct from each other. Because if we don't, well, we can mix them up and compiler will tell you nothing about the problem that you have just made. So what can we do in Scala to implement value types? Raphaël?
We can do a lot. And yeah, even it's something I work a lot onto because I presented some talks about refining types, which are putting into the type system all the constraints a type should have. So yeah, maybe I will show you some journey in
Please do.
we can have. So this screen. So here, as you say, we have a classic IBAN number, which is modeled in that's the French IBAN. IBANs are different between countries, but here it's a French one. So we have only strings. So it works. It works, but when you mix, it also works. It compiles, and it will break somewhere else, and you can give it the value you want. So there's several methods. First, you can just alias the types, but this one the problem remains the same because aliases are just for the devs. That's not for the server. So what is close to value objects? It's value classes that we can define, just basic records, single value records with extends anyval to avoid some instantiation. And here when we mix the order, it doesn't compile. But with a simple thing, we can still put some weird invalid values. So we can add some validation. Here you'll have so if you check here, you'll add the safety, the type safety, and if you're using either or validated or something else to the parsing, you can you add the referential transparency that you didn't have before, or if you throw an exception if the value is invalid or something else. But here you see that's quite verbose. And refine types, it's the main it allows us to easily express our constraints into the type system. So here, the same example, we're using country code. Just here, it's an opaque type because it's Scala 3, but it could be just a type. And here, just some plumbary for iron, which is a lib I recommend. And now we can just, if we have static values, we are expressing just as the same at the first time, here and here, that's the same code. But here, if I put another character, it will not compile. And so that's great for compile time values, but also we can also have at runtime. And here with these libraries, we'll have everything value classes brings to our safety, plus the readability. Here, thanks to Scala 3, it's zero cost abstraction because everything is inlined in the type system. And yeah, it's we're using it in all our projects. It brings us safety and readability to the cost of just 2 lines except of 1.
So let's quickly recap what is the benefit here, because if you could go to the basic one, so 0, 1.
Yeah.
So what we have is just a case class with fields that are strings. Everything can be shuffled, and there is no type safety here. You do have data that you can easily match on, but it can be messed up. If we go back to the iron one, so those are still strings, right? What I think needs some explanation is that
they are strings. In fact, if I extract a value and give it the type, okay, it doesn't want. So here it doesn't exactly. It is not exactly a string. It's a string that has a fixed length of 2. This one, in fact, the iron type is just an intersection type. So it is a string, but it is also something else.
Yeah.
It has some constraints.
It's a string with properties. So
yeah, exactly.
What I love about this is that with library like Refined or Iron, you also get the runtime validation code, right? Because this either method, it's not something that you have written, right?
No, I didn't wrote it. It's given by this magical Refined type ups that brings I don't know if I have I don't have the sources here, but we have this thread. So we have a lot of utility method to parse as a negator, as an option. There's also, if you're using cats effect, for validated or non-empty lists, so on.
There are integrations, true.
A lot of.
So one last bit that I would like to add here. So opaque types are kind of interesting feature of Scala 3 that they are expressed as strings in runtime. So there's no wrapping. That would also work with anyvals, right, in Scala 2. But there are cases when they do wrap, when they are but that doesn't happen with opaque types in most cases now. Okay. So Voytek, I have a question which is a bit tricky in this regard. There's a critique that I often hear about this approach. I am a big fan, to be perfectly honest. I very like refined types and opaque types, and I try to use them when possible. But the critique is that this is an approach that doesn't really pay its own debt. So would you say that this is something that pays off in practice?
I think that's a very good question, and I think that it's very good that Raphael showed us the spectrum here, because it all depends. At a certain point, answer to almost any question is it depends, and here it's also the case. So it just boils down to how often you use that particular type, how critical for the correctness of your system is that type. So we can look at two extremes here. If you have a value used only inside the method, like similar to mutability, you can have tactical mutability, you can have tactical strings. It probably doesn't justify introducing a new type, right? If that value does not leak out. So this is a one extreme. And then you can imagine a very core data type of your whole system. For example, in the same domain that I showed you mine example, the accounting, it's very important that all the amounts that we use are positive, because otherwise the whole system breaks.
Yeah.
And in that case, we take a lot of value from refined types. And those are two extremes. And there is the whole space between when you have to judge what does it make sense or not, and which approach to take, because you don't always need refined types. You might go for a softer version, like just the enevals, and that's, I think, exactly what we are being paid for, to make those calls and assess those things, because at the end of the day, those tools are not that hard to understand and use. What is hard is to know when to use them, and those make sense.
Yeah, I fully agree. I think it's an illness that often finds junior developers that learn about those techniques. I think I did also some things in this regard where
We all did.
yeah, it's part of the learning experience, isn't it? Where I basically poured concrete over the whole domain, and made any changes very, very hard to do because everything broke in so many places. So yeah, I fully agree on thinking very hard about whether this is a good choice to do. But since we're already speaking about the hard parts of using those things, refined types, opaque types, Raphael, I would like to ask you, because you did this presentation about iron before.
Yeah.
I would like to ask if there are any downsides that you're familiar with, that you have encountered, problems that people should be aware of when using those techniques.
Sometimes, as it's deeply in the type system, when some errors arrive, it can really be messy because of the non-resolution, implicit resolutions. So it's kind of hard, but that's not so frequent. And the other part, I think, it's maybe when you're using some other libs that needs derivation again, you have to write the bridge between iron and the lib, but that's not so a really big problem, because there's already a lot of integration for CATS, Zayo, the thousands of JSON parsers. No, I think that's 5 or 6 parsers that are integrated, decline a lot of things, and it's really easy to write an integration. I'm checking if I can find one slide. Yeah, I got it. So I will share it here. Here you have the whole integration of Doobie for Iron.
Okay.
So that's just this, and for Zayo, it's there's this single line too. That's not so complicated to write one.
I would wanted to say I would respectfully disagree, but
yeah.
yeah.
Here,
it is. If you know what you're doing,
the easiest.
Yeah, if you know what you are doing, it probably is. I would because this part, if you have AI and you can ask it about some details about how that library is implemented, like Doobie in this case, I guess you can swim to the shore pretty easily. What would really, I think, scare me is what is the error that led to the realization that you have to do this thing? Because you would just try to derive an instance for a case loss and it would just fail, right? So you have to understand this bit. Yeah.
It will fail. It will fail because that's not the good type. So it won't fail the implicit converter, not converter, but mirror. And here for Doobie, it's meta.
Yeah, it's a bit unfortunate that opaque types do not, at least yet, they do not still support auto derivation.
No.
Okay. So I have another question. You've already mentioned CATS, which is a functional library that provides functional abstractions that are quite popular in Scala. They have been very popular for almost a decade now, I think. It's close to a decade, isn't it? I would like to ask if that's something that you use in the main code. So functional abstractions like monads or functors, applicative functors, which are hugely useful, or on the other hand, for data monoids or semigroups, are those abstractions that you use in functional code? Domain code. Voytek.
Yes, to an extent, or once again, it depends, because they are useful and they allow to reason about the code in a kind of structured way, predictable way. I'm speaking specifically about, let's say, monoids and semigroups. I think those two are particularly useful in domain modeling in some sense. The problem with them that I have is that it's very easy to get away from good domain modeling because you are introducing the language that your business doesn't speak, right? If they speak about the account balances, your accounting faults, they don't tell you this forms a monoid, right? So
I would like to see you try.
Yeah. So that's the risk here. So you can use something that makes a lot of sense from the functional perspective, but you take the risk that you're going away from the business model and the language that your business understands. So what I sometimes do is that those kind of abstractions are implementation detail. Like I define them just to have a structured definition, but then I use them through a dedicated like merge or something that is more natural. So yeah, that's my take on those abstractions.
Okay.
For the monads, functors, applicatives, I don't think those are that useful in the context of domain modeling, because yeah, just data is more often modeled.
Yeah, Raphaël, if you have
maybe about we're thinking about effect that here we're using it a lot to describe it, so our behavior model between things that have side effect or pure. That's here. It brings some value just to say, okay, it is effectful or not, and it brings also to the attention of the stakeholders that okay, these calls are different, and yeah, it's something we use a lot.
Yeah. And I agree with this one. We have a very similar approach. We use I/O a lot to distinguish effectful and non-effectful computations. And I think that's a good example of where the tool is useful. Like, even like, it's not exactly solving the domain modeling problem, but it's still useful in that sense. Another example, because we use it to track side effects, and this shows up in our model as a return type of the function method. The another example of that case where it's just a tool useful for a higher goal is that I have this proof of concept library, right? Like workflows for S, and the primary abstraction there is a monad, and the whole library is built under assumption that, like, with the primary goal of bridging the gap between software and business, because the one thing it does, it renders the flow that you can show to the business. So in that case, you use something that is a tool, it's technical tool, a monad, but you build something that is actually close to business.
Okay, I wanted to make a remark, because what you are saying is, if I'm getting you correctly, you are saying that actually effect tracking is commercially worthwhile, and that's something that is kind of funny, because a few years back, John DeGoes wrote a big blog post about how the effect tracking itself is commercially worthless, and that you get value from asynchronous runtime that allows you to write correct programs, but that's a very good point about that. But I would like to dig into that. So you mentioned that, Raphaël mentioned that if your stakeholders take a look at code and see that there's a piece of code that returns an I/O, they know that it's side effecting. Is this something that really happens? Is this something that really happens?
No. I think it happened once, and we had to explain. But yeah, at least it brings discussion, and we say, okay, this part, when you see the error, it's because it was an external system call, so and the fault was on the external system. So this was the case to explain. That's why we are putting this effect, because it can it's not a pure computation.
Yeah, I guess even if we sidestep the topic of shareholders looking into code, which I don't believe happens so very often, but I
it
think
depends on your stakeholders.
Okay, I'll believe you here. Never met such stakeholders yet, but I believe that there might be some people like that.
Actually, that's a good topic, like a small remark here, because we are talking about the business domains, and something that is usually neglected is that a technical domain is also a domain. Like if your product is technical, then your domain is technical and your stakeholders are technical. So you can think about, for example, a Tapir library, or maybe closer to you, Łukasz, Besom. Like it's a product in technical domain, right? So the stakeholders naturally will be technical. So it's hard to say universally that those certain things matter or not for the stakeholders and the business, because it really depends on what kind of the domain you have.
Okay,
yeah, and
that's
your APIs too. Your APIs you're providing are expressed in your domain.
Okay.
So,
okay, those are fair points, but I would like to drive this point home. So, would you agree that it is an additional value that you get as developers working with code base, that you can discern between functions that are pure, so they don't return an IO, right? And functions that have side effects and they require suspension into IO.
Yes, for me, yes, the fact that for me one of the biggest advantages during the code review, so you can easily spot misunderstandings or like misassumptions. Like you assume that some operation is safe and non-effectful, and then you see IO, and then this is a trigger to start a conversation and dig into what's the implementation that you were not expecting. So for me, that's a big value here.
Okay, this is very interesting to hear.
Yeah.
Just to dig a bit deeper into the topic of type classes, I have a note that I wanted to ask about type classes that operate on higher-kinded types. You already mentioned, Voytek, that you don't really use monad or functor in the main code. Just wanted to clarify, do you see any value in using higher-kinded types and type classes that operate on them in the main code? Or is this something that it's just type astronaut thing?
That's once again, it depends. So the topic of, I think this is a topic of how granular your effect tracking is and what do you want to track. Because if we operate on this fine-grained type classes and have just the absolute minimum of power to implement an interface, I'm talking about tagless final, just to so it's clear. So when you have an abstract F polymorphic type, and then you bound it with some type classes that gives you the behaviors, right? And you can say it's a functor, monad, async, whatever, and then you have a very fine-grained control over what you expect. So for me, that's too much. Like I don't find it useful. That's maybe it's just a matter of scope, of how critical for your system that is. But in my experience, it doesn't bring the benefit. It's like at the high level, knowing if it's effectful or not, that's useful. Knowing if it's a functor or async, not that much.
It may depend on your domain, because the same thing is your product is addressed to developers. So you're writing a library, then I think it can bring it brings some value. But for, I would say, the final programs, you don't have. I think you don't have to use tagless final and stick with IO or IO. It's perfect for the use case.
Okay. Another bit in this segment, in this topic, basically, is what do you think about monads that do suspend code? So it's basically a discussion about pure code, which is suspended, and you get value, and the direct style, I would say. So would you say that there is some benefit to be obtained from using suspending effect systems like Katz effect or Zero or Kaio in domain modeling, of course? Voytek?
Yes, it's a hard question to answer because I can't really imagine myself doing it any other way around. But like that, just maybe survivorship bias or just getting used to it. But I like to operate on values. Like I don't like that stuff is done if I didn't ask for it. So I like to return values, and that's what suspended computation is. Then I can handle the errors gracefully at any point in time. I can transform it. So it applies to both the I/O, the streams. I sometimes have to still work with Akka streams, and it's a big change of mindset to know that the things run kind of as you write them, and you cannot just take a stream and transform it like without side effects. Like, yeah. So that's my take.
Okay, Raphaël?
Yeah, I think it's hard for me to since I'm doing Scala. I've been using effects, so and I haven't tried really tried yet direct style for professionally. So it's I don't know whether what are the real benefits. Maybe I think that there's some, but not as Voytek said, where manipulate values. So yeah, when we're defining our code, we just describe what it's done, and it's done when we want to be executed. So yeah.
Okay. Okay. So last question in this area, I would say, that I have, and it's a bit about something that was popular way back. I mean, some are probably around 2017, I think. So free monads were a big topic back then, and free monads are basically a way to change the encoding of operations into values. So basically you implement them in a way where all the operations are encoded as data, and then you describe processes in terms of those monads, free monads. You compose them, and only then, after you get the full description of the process that you want to run, you execute that. Is this something that ever happens? Do you ever use free monads in your code bases, Raphaël?
I don't think so. No, okay. We are not using it.
Voytek?
It depends.
Excuse me. It depends. Okay. That's going to be interesting.
Because, okay, about the free monads themselves, there was a very short period of time when I understood them. It was like, as you said, 2017 or around. And then I already forgot, and I no longer know how they work. But I get the idea. And the concept of declarative definition of programs, where you build a data structure that expresses your behavior, that idea is not that arcane and weird, and that's actually how the workflows for S works. So there I built a custom data structure that captures all different behaviors going through different steps, and then I interpret that. So It's not a free monad because I don't care, but it's a custom data structure that declaratively describes your program. I need it. I need it for a very particular reason that is not available in any other way, is that I need ability to render it, and I need that ability to get closer to the business, right? Because I want a diagram that I can show to the business, and for that goal, I employ a semi-arcane mechanism of expressing programs as declarative values. And so, there is a connection, but not in application code, definitely.
Okay. So the idea has survived, but not the implementation.
Yes.
Okay. Okay, so you've already mentioned one of your libraries, so I'm going to go a little bit off script here. There's another technique that is also lesser known approach, which is hierarchy data. I am aware that you are building a library that is based on hierarchy data, which is a companion library to workflow for us that is called decisions for us, right?
Yes.
Could you tell us something about hierarchy data? Is it useful in any way in domain modeling?
Yes.
It depends.
Yes, it is. It depends. Yes, it depends. Because it's useful, but I don't know if it's actually useful in domain modeling. But maybe I will show you what it, for the folks who don't know the name, what it means is that we just define a case class, and then we wrap all the fields, or it doesn't have to be all, right? But you wrap the fields in the abstract type parameter, type constructor, actually. And that's it. That's hierarchy data. Okay, so nothing too magical. And the point here is that you can reuse the structure between different use cases. So we have a structure. So the structure means there is a name of a field, in that point is name or age, and there is a type of the field, which is string or int. So that's a structure, and then you reuse that structure for different use cases. So, for example, you might imagine that you're inserting data into the system, right? Or basically creating the object. In that case, your f becomes id, so you have just row values, and this is one use case. But then you might be patching this object, applying some, changing some values. So you can have you can fill it with options, so you patch only certain fields, right? You can also express modification that way, like something with a function, right? So you can do something that's, for example, like that transforms. You can fill it with functions and just define the transformations that you apply to all the fields. Another trick is that you can fill it with artificial values. So with that trick, with the const, you ignore the string or int, which goes here, and you just define this predefined value. So in that case, we have a data, the same structure, filled with just strings.
Oh.
And you can, so this can express a hashes, right? Like you could hash each field and have a string and still persist it in the same data structure. So that's a technique. Now, if that technique is useful for data modeling, I don't know, but I think it's worth knowing. It was definitely very useful for decisions for us, where I use the same input and output case classes to model the input and output of decisions, so of the conditional logic. So you define the rules for each field, you define the input values for each field, then you can render it to string, so each field becomes a string. You can evaluate the rules, so each field becomes a Boolean, and then it works like that. So it is a technique. It is useful in some way. Is it useful for domain modeling? I don't know. Probably yes, in some domains.
Well, you could, I think, say that in the domain of decision tables, it does make sense.
Yes, exactly.
Okay. That's actually very interesting. I think it's one of the lesser known approaches in Scala, but it seems very, very powerful if used correctly. So
The problem why it's not very popular is that it's not exactly easy to operate on this data classes. Like, imagine you want to merge two instances of data together, or like apply that patch. How do you do it? Like, you have to wait to generically iterate over fields of different types, right? And get fields from both and then merge. So in decisions for S, I have a custom type class for that, but there is also a library, I believe, that's called like HKD for S, a relatively fresh one that gives you that out of the box. So maybe lack of this kind of library was the reason this is not popular.
yeah, something that would enable adoption of this pattern. Yeah, I think we'll have many such patterns in Scala that are just being refined as people experiment with them, and maybe we will get more of useful techniques like that. Just to clarify, Raphaël, did you have any use cases for hierarchical data in your system?
We're not using it definitely for now. I haven't looked for maybe, but I couldn't tell anyone. I'm sure I'll look very soon.
Okay.
Yeah, that's why it's worth knowing the technique, because then
Yeah.
you can easily identify the use case when it comes. But like if
Yeah.
you start, like you might not have seen it before. Yeah.
Okay. So I have a last bit that I'm interested in, which is also a lesser known Scala feature. And I've heard about this feature being used to limit the possibility of calls in invalid states, which is something that is quite a common problem, I would say, in multiple models of domain. I think the most basic example would be a finite state machine. I'm talking about phantom types. Phantom types can be used to make things only possible when your data type is in some type that is expressed with this type. Guys, do you have any experience using phantom types to do such operations to limit the possibility of wrong calls in your systems? Raphaël?
We're not using it. Maybe to, as you said, it's not well known. So I don't think we're using it, at least intentionally, because I'm sure somewhere there's some traces of it. But yeah, phantom times we don't have it. But I think Voytek may have.
Yeah, an example. But please, Voytek.
Yeah, that's actually a funny question, because I don't know if you remember when you asked me before the podcast, do you use phantom types? I also said no, because I was kind of not aware. And only then, after some deliberate thinking, I realized, yes, and it's at the core of the system I touch. So yes, I can show you. So almost the same abstraction that I shown you at the beginning, the account. So a label for funds. In practice, this is a bit more complicated, because the accounts are grouped in something that is called chart of account. That's a term from accounting domain. But what it means is that you can have user accounts and you can have a company accounts. Like in that case, it's SwissBorg, so the company I work for. we have our own internal accounts. They are both stored in the same system, the same ledger. Now, what is important is that under no circumstances you're allowed to mix the two. They have to stay separated all the time. It makes absolutely zero sense to move funds between SwissBorg account and user account. Like this doesn't happen at least on that level. Like it can happen on different level, but not when we are talking about accounting. So those are two very separate bits. So how we express that is that the account is parameterized with this abstract type. The name is just like letter for convenience. It could be anything, but it's just some type parameter that gives us the type of the account. And then we parameterize a lot of things with that type parameter. So the chart of account is parameterized with that. And the chart of account is actually an enum of accounts of that particular type. So we know it's a user account or a company account. We can see it here. So the user account is a chart of type user, and the SwissBorg is the chart of type company. And then when we go from there, like we have ledgers. So a ledger is just a set of balances for some chart of account, right? So we can have balances of the user. So this is it. You have a user ID. So for a particular user, we have the balances, or we have our own internal balances. Then there is an abstraction that we use that is like a movement. So basically a movement of money between two accounts. And as you can see, this is also parameterized with this the same type parameter. And then we have actual balances. So like just the connection expressed this way. I'm not sure if that's expressed this way in the system, but it doesn't really matter. The point is that you connect the ledger, and so the chart of account with the movements, and you on the type level ensure that they are of the same type. So through that, you ensure that your movements always touch the accounts of a right chart. So yes, this is a phantom type. This type does not have any use outside of it, but it's very crucial to the correctness of our system.
Okay, thank you. That's illuminating. Okay, so I think we went through all the features that we wanted to talk about. Let's talk about the migration. So that's the big topic that is still pending. And just to start, do you guys both work with Scala 3 right now? Are you already on Scala 3? Raphaël mentioned that Ledger is using Scala 3 exclusively. Yeah. Voytek?
Yeah, in our team since 2 years now, and whole Ledger, I think now since 6 months ago, there's no Scala 2 anymore in Ledger.
Okay, and SwissBorg?
It depends. So yes, we started the migration efforts. We have, I think, at least a good bunch of services running on Scala 3. Another rest of them are still run on Scala 2. So yeah, we are in the process. Like we solved all the blockers. Now it's just that each team needs to find time to move their services to Scala 3, but everything is ready, and some of them are running in prod on Scala 3. So
sure, yeah. But that means that was just the entry to the main question, which is that we can assume that you have exposure to Scala 3, and it is a valid question to ask you whether you can say if Scala 3 has improved the experience of domain modeling in Scala, or I don't know, degraded it in some way. So what would you say? You are already speaking, Voytek, so if you could continue.
Yes, I think it improved a lot of things. So even the enums alone, they are just more comfortable abstraction to model stuff. Like it takes less code to model it. But also opaque types, they are a big help. Like just it gets easier to use. Like everything that was possible in Scala 2, or like most of the stuff that is possible today was probably possible in Scala 2 one way or another with enough macros and hacks and other stuff and implicits. It's just that Scala 3 makes things much easier, much more convenient to use, that now we will see the actual emergence of better techniques and better tools.
Raphaël?
Yeah, me too. And I think that Scala 3 is a major improvement in domain modeling, enums, opaque types, but also intersection and some types, because it allows you to directly express in the type system all the type system improvements from 2 to 3 are that's a huge thing. I'm sure I would have some trouble going back to Scala 2 now because I think I'm exclusively doing Scala 3 for 2 years. So going back with the whole quirks and the hacks for the whole novelties, it's I don't want to be back there.
So could we agree that Scala 3 lowered the bar to entry into more precise domain modeling? Yeah.
Definitely,
and the whole bunch of things we can do directly in the type system, but after it really demands some knowledge, but to do this in type system. But it's awesome. A colleague even put the date computation in type system directly with the leap years and so on. That's something we couldn't do before.
Yeah. And if I can add to that, there's one more thing here, which is like there's a lot of features that help in direct modeling, but there's the maybe even bigger space of things that indirectly help in modeling. So the both decisions for us and workflows for us that are business-oriented tools would either be not possible or very awkward to use in Scala 2. They are both written in Scala 3, and as I said, they are tools to get closer to the business, but they would be much harder or impossible to write in Scala 2.
Okay, if I may ask you about the details of this, why would they be impossible or very awkward to use?
Yeah, so in decisions for us, I use, for example, implicit function types to get the to do some stuff. I also use the derivation that like makes the user side much smaller. Like the impact on the user is smaller. They just do derives HKD to be able to define some stuff. I use a lot of the polymorphic function types, so the types that work for any type that were required shapeless or very awkward to use. In workflows for us, I use the match types for embedding one workflow to another. So I could probably overcome all those issues and write it in Scala 2. It's just too much work, too much hassle, and too much impact on the user that to make it feasible.
Okay, I agree. Actually, we have very, very similar observations. Okay. So let's move away from pure Scala, from the language itself. let's talk about patterns. There is one design pattern that is very closely related to the whole discussion about DDD. And it was, in a way, mentioned in one breath, usually in the discussion about DDD, which is CQRS and event sourcing. I would like to ask you, because Scala has been popular destination for anyone who wanted to implement an event sourcing system due to akka persistence module. And this has been going on for over a decade, I think, right now. So I wanted to ask first, do you had this experience in your career of implementing systems that used event-based approaches first and did event sourcing, did CQRS? And if you had this experience, well, how did it went? How did it go? Sorry. Voytek?
Yeah, I can answer that. So here there is a bit of a story, because the 4 years ago, before I joined SwissBorg, I had exactly zero experience with event sourcing, and over the years I was gradually learning more and more, and working more and more with akka persistence in particular. And the more I work with it, the more I admire how solid tool that is. I'm still not a huge fan of akka as a, I'm closer to types of fully functional programming, and this is hard with akka. But the persistence and clustering, those are very, very strong, solid modules that we use quite extensively. And they make a lot of sense. The only caveat is that it depends. So we have it. I touch on a daily basis, maybe, I don't know, 10 services that I'm well aware of, and I know the internals of. And among those 10, only 2 use event sourcing. So it's a tool, and you need to carefully evaluate, does it fit the use case? So yeah, that's my experience.
Okay.
Yeah, and for us, we are not using directly event sourcing. We're in a functional programming way are using the idea of events, and yeah, because some to be some transaction, it's an event, and from this event we are doing things, but we didn't want to have the deployment complexity, let's say, of a cluster, and so we went to let's say traditional FP.
Okay, so services.
Yeah.
Okay. I kind of hoped for something controversial here, but no, it's just the usual plateau of productivity, right? Use it where it fits.
That's what drives the business.
Yeah.
If you want a controversial take, I can do one. It's that I'm not sure the events modeling things as events is that useful for domain modeling. Like, okay, so when you look at the origins, it's like how it's advocated is that you have a business events, and those you store in the system, expressing the system, and that's very close to the topic of domain modeling. And while this is correct, my feeling and a bit of experience is that sooner or later those events gravitate toward being technical ones. Like you just add more and more of technical or implementation details to those events, that it's not a really good tool to express domain logic. Or it is, but it can also not be, depending what are those events and their level of abstraction.
I think I know what you mean, like events of kind of email send, right? Yeah.
Yeah.
Okay. Okay. So before we finish our discussion about domain modeling, I would like to take a break from the purely technical part, which we do daily as engineers. But I would like to talk about our relationships with people that aren't necessarily programmers, aren't necessarily engineers. They might be, depending on the domain, of course, as you mentioned before. But those are people that we usually tend to think about as the business people. I would like to ask you, as you both have extensive experience and long careers, what insights could you share about things that technical people, so programmers, should have? So skills, understanding about our relationship and communication with people that we call the business people. Voytek?
Yeah, that's a topic very close to my heart, especially recently. So I think that I would start with trying to define what is business, or like maybe give an intuition to the people what we mean when we talk about business. So it all differs between products, but it's I usually, when I say business people, I mean people like operations, so the agents that use your system, right? They might click through the back office of your system to do some stuff. So this is business. There might be people in the accounting department that like keep your company, like finance of your company in line. There might be like experts on particular domains, like the payments, like someone who just knows how money is transferred over time. It might be a product owner. It might be I don't know, the CEO, right? Who just have the vision of the whole company. This is all business, right? And then what is critical to understand is that all those people speak different languages. Like you might think they all speak English, but that's not true. They all speak different languages, especially if you start talking with legal, for example, or compliance.
Oh, yeah.
And that's the one thing I learned is like, for a long time I thought legal and compliance is the same thing. I learned it's not. Yeah, so all those people, they speak different languages, and at center point, when you start talking to them, you need to learn their languages, and your role is to translate the technical language of developers. That's especially applicable to staff engineers and above, that like we have to translate between the technical language and the languages used by those people. So not only by the generic business language, but also to specific language understood by legal, by finance, by whoever else. So that's a skill you have to learn the more you talk with the business. And you have to talk with the business to understand why you're building what you're building. I think that's the core idea here. You have to be close to the problems you're solving, and there is no way to be close to that problems if you're not close to the people that either create or define those problems.
Yeah, and the why is the big thing. When you have to communicate with business people, but yeah, that's basically all people in the company that is not you. Even, let's say, even maybe some other teams that are external. So you have to understand why they're doing or asking what they ask. And it's your job to translate it, to understand what they're doing and why, or at least ask them why, so you'll be able to answer and to develop what you're writing. And if you're not talking, I think if you're not talking to business people, I don't see how you can write some good code. Maybe it will be performant, but it surely won't be the code that will really fix the business problem.
Yeah, I think I know what you mean here. I think it's well, I don't want to say common because that's a bit disparaging for our community, but I think it is a stance that sometimes we encounter among our colleagues, that understanding what that thing that we are implementing is, what it actually does, is something that business analysts should understand, not me.
Yeah.
So yeah, that's something that is I think not really underlined enough. Not really. There's not enough emphasis on understanding why the things we are meant to build are meant to exist in the first place.
Yeah. Yeah, and I think we have a bit of that problem in Scala, to some extent at least, because if you think about Scala, the major things that you associate with it is like, it's functional, which is a technical concept. We have a distributed akka for building distributed systems, and that's and the actor model, and that's a technical concept. Then we have a Spark, which is okay. It's a bit domain of the data engineering, but it's still a tool, kind of technical. Like most business folks will not tell you to use Spark; they just want the data out. So then we went away from Spark and we got into effect systems, and it's once again a technical concept, right? And we talk about categories theory, which is also, I don't think, the domain that most businesses care about. So we hear about all those things on various sources, like conferences, podcasts, whatever. That's like what drives the community in a big, at least big chunk of it. And then we automatically associate this as cool, important, and something that we need to learn, right? And we very rarely speak about this kind of the business side of things. And that's exactly why I started the Business for S, because I wanted to put a counterweight to all those technical things, just so we have an equal conversation about both the technical aspects of the job and the business and soft aspects.
Okay, so what would you propose that we should introduce as practices? What would be the good practices to, make those relationships flourish, the relationships of business people?
Maybe Raphaël has an answer to that.
I don't just wanted to continue what you said before, Voytek.
Sure.
I think you're perfectly right about saying in Scala where we have the tendency to drive to be driven by technical, but that's funny because at the end the main reason we're using Scala, it's not the technical thing, but the productivity, the quality, and that are the benefits that want the business also, and that's really fun to see. We're coming from a technical point of view, and it brings us business value.
Yep. So we should probably get back to the Łukasz's question.
If you could.
Yeah, and so for your question, what can be done? First, you don't understand people when you're not talking to them, and you're not talking to them because you don't understand it. It's a vicious circle. So first, you break this circle. You're gonna talk to your colleagues and let's say explain or maybe let them let you do some of their stuff. Sometimes, yeah, for half a day. You'll see what are their pain point, their vocabulary, and so on. So that's something that always brings value. In the other way, bringing business people doing our job, I think it's way more difficult because of the technical aspects. But at least yeah, some discussions. It's the basis.
Yeah, I can also add to what Raphael said is you will talk to business and you will suffer. It will be painful, awkward. You will have miscommunication issues, or you will like different people's talks in a different way. So it won't be a pleasant experience, but you will get stronger out of it. So yes, you have to start talking to the business. You have to start asking why. Actually, I did an exercise recently, and I wanted to, among all the people I know, find great engineers who don't understand their domain, who are not a domain expert one way or another. And I couldn't find any. Like all the best engineers I know, they deeply understand the domain they work in.
Yeah.
Yeah. And if you ask about the practices, then the one thing we did is that we sometimes do pairing sessions. Like we send engineers to work as agents, so they do the manual work that our operators do, or either the KYC processes or payments processes, just for a couple of days to have an exposure to that. So that's something that can be done.
And customer support too.
Yeah,
that's that's where I learned a lot of things about different companies I worked in doing support, and you see how your product is used, what are the pain points, and what are the areas you have to focus on. It's beneficial for everyone.
Interesting. Okay, so among the techniques that you suggest from the soft side is to change the perspective often, go to the people that you work with and see how what you build is actually being used, how, in what way it's being used, and what the pains are, and what the customer sees, right? So what customer reports as issues. I think that's a very valuable perspective. Okay. I think we're getting to the end. I would like to ask you about the stuff that we have discussed today. Which of these techniques have brought you the most value? Which had the most bang for the buck? Voytek?
For me, I think it's new types. So the value types, like the fact that you put two strings next to each other and you cannot mix them up. For example, user ID and transaction ID are different things. That's like the cheapest, because it requires even zero machinery, like just a case class, and it creates enormous value from both sides, like both the correctness and the modeling, because you start speaking a language, a specific language, other than string. String is not a business language. So I think that has the biggest ratio of value for money.
Okay, Raphael?
Yeah, I think that's the same there. The thing that but the biggest value for less is know the type system and how to use it. So it's it's new types or end or refine types and ADTs. That's that brings so much confidence, quality, and for really small cost, brain cost, I would say. It's even easier after to use it, and because at the end we're reading more code than we're writing. So if we can save us from a mental pressure, and this is bought by the type system and how it is expressive.
I'm very happy that you mentioned refined types and opaque types, specifically because that's one of the features that Java doesn't have, and I don't expect them to have them anytime soon. So, okay, we're good. Okay, so it is customary that at the end of the podcast we check what the chat has been doing, and if there are any questions. And there has been a discussion. I'm gonna skip the discussion, but there is a question. So Roman Greshny is asking, do you think the Scala ecosystem needs more guidelines or approaches for building apps like the Ruby on Rails convention over configuration? What do you think? Should we have more defined approaches to defining applications?
I think we may have some convention or tools that help us, but always be able to do whatever we want with the language, and that's one, because that's exactly why I'm writing pillars. Just so we can just think about our business domain and business code, and don't care about the whole infrastructure stuff. And yeah, I will say that we need it, because I'm writing something for it. But yeah, it's also a way to I think bring some other developers to Scala.
I agree. It's a good productivity buster if you start with something that is a template and you only have to fill in the gaps, unless you need to go off the reservation and do something that is very different to what the template expects you to do. It really helps with the velocity. Could you briefly explain what Pillars is, Raphaël? I know that you are building it, but I only looked at it as a set of components. Could you?
Yeah,
describe?
in fact it's I would say it's a platform, because it brings just some an entry point for a backend service. And you can optionally, no, in fact, in core, you have observability that are already defined in the whole core of Pillars. So each HTTP call is traced, each DB calls is traced, and the trace are linked, and metrics, and you have also some integrations. In fact, it's just a curated set of libraries that are put together, and so it can be really be used easily. It's yeah.
Okay, so
but basically at the end
template.
you, yeah, and the only thing is just you have it's based on basically context function, where you have the main context that is given to your business code.
Okay. So Roman has another question related to the one before. Could these guidelines include using approaches like clean architecture, DDD, business for us, and pillars for the infrastructure layer, and BSOM, of course, for DevOps? Okay, could they? I think they could. I think they could. Yeah, that's something to think about. So we have some development in BSOM that is going into the integration of infrastructure layer with service layer. So definitely something that we can and probably should look into. I think that we have a discussion about phantom types in the chat, but no more questions. So I guess this is it. So thank you to the guests. Thank you for being here today with us and sharing your knowledge and understanding. And well, thank you to the audience for being with us here today. Cheers.
Thank you.
Goodbye.
Thank you. Bye.